Hello all, we're going to be going over the Algebra 1 January 2018 Regents exam. In my previous video we went through numbers 1 through 6, so we're going to start with number 7 today. I'll place the link below for the PDF file of this test. Okay, I also started with a clear calculator again, just so you know there are no previous settings in there. So let's take a look at number 7. Last weekend, Emma sold lemonade at a yard sale. The function P of C equals 0.5C minus 9.96 represented the profit, P of C, Emma earned selling C cups of lemonade. So C is the number of cups for lemonade. Sales were strong, so she raised the price for this weekend by 25 cents per cup. Which function represents the profits for this weekend? So we have to identify what each of these numbers represent in this linear function. So we already know that C represents the number of cups of lemonade. So 0.50 represents the price per cup for each lemonade. And then this minus 9.96 represents the initial amount of money. So in this case, she must have spent $9.96 setting up her lemonade stand or whatever it is. So this is the initial amount of money. Okay, because a lot of Regents questions do ask for you to identify the different pieces of a linear function. So that's what each of these represent. So if she increases her price 25 cents per cup, then that means that this 50 cents is going to become 75 cents. And she still spent the same amount of money initially, but now her function is going to be like choice 4. All right, for number 8, the product of the square root of 576 and the square root of 684 is. So you'll see that they're asking whether it's irrational or rational, and then about each of the factors. So I'm going to start by placing the square root of 576 times the square root of 684, because the product of represents multiplication, or the result of a multiplication problem. So in my graphing calculator, second x squared gets me the square root symbol, 576. I need to come out of the radical by pushing the right button here, times the square root of 684. And I try to turn this into a fraction by pressing math, enter, enter, and it does not become a fraction. So this is 627.68144479, and it goes on forever. So this is an example of an irrational number. So right off the bat, we can get rid of choices 2 and 4 because our product is irrational. But now, what is this question about both factors are irrational or one factor? So when we have a product, this is created by a factor times a factor equaling the product. So we already identified the product as irrational, but what about each of the factors? So individually, I'm going to place the square root of 576 into the calculator, and I get the number 24. This is rational, so I'm going to just identify that with an R. And then for the square root of 684, for the square root of 684, we're going to get something that also, by pressing math, enter, enter, becomes a fraction, but the calculator rounds this last number here because it obviously cannot go on forever and ever. Otherwise, your calculator would never be able to do anything else other than continue calculating the square root of 684. So if your calculator ever does this, this kind of looks really crazy. So if you wind up with something that's a crazy fraction like this, with 57,799 over 2,210, like that's crazy. That means that this is an irrational number because the calculator mistakenly creates a fraction based off of this number if it cuts it here. But we know that this number has no pattern and should continue on forever and ever. So the answer is irrational because one factor is irrational, because our first factor here is rational. All right, if we take a look at example number 9, which expression is equivalent to y to the fourth minus 100. So just looking at my choices, it looks like they factored y to the fourth minus 100. And you can factor this using the difference of two perfect squares, also known as dots. There are a lot of videos online about this. So y squared times y squared are the two identical factors that multiply together to make y to the fourth. And 10 times 10 are the two identical factors that multiply to make 100. So the difference of two squares states that you can take each of these factors, place them inside parentheses. One will get a plus and one will get a minus. So this is going to be example 3. Choice 3. So we can actually take a look at this in the graphing calculator. Since it says is equivalent to, we can treat this like one side of an equation. So I'm going to go to y equals and type in y to the fourth, which I'll just replace with x's because it doesn't make a difference. And I'm going to test each one of these choices as y2, because what I'm going to do is figure out if they are equivalent. Meaning, if every time I put a number in for y, I wind up getting the same value. So if I take a look at the table, you'll notice that y1 and y2, meaning this original expression and this choice, do not match. So they are not equivalent. So just to save time, I'm not going to go through the rest of them, but when you get to choice 3, you'll notice that when I type in x squared plus 10, x squared minus 10, and you look at the table, your y1, our original, and our y2, our choice, always wind up being exactly the same. So that's how we know they are equivalent. All right, let's take a look at example number 10. The graphs of y equals x squared minus 3 and y equals 3x minus 4 intersect at approximately. So this idea of an intersection point is when I have two functions that cross. This is the solution to both equations. Okay, so that means that when I put the x values, so these are all xy values, I should get the same x and y for both of them. Now this is a quadratic, so it may look more like this, and I might have two intersection points. Okay, but you will be able to see that if you look at it graphically. We're actually going to take a look at the table. So if I go to y equals and I type in my first equation into y1, and then my second equation will go into y2, 3x minus 4, I can go to second window, and I'm going to change my independent to ask. So second window is the table setup, and if I change my independent to ask, I put it in this mode because I want to tell the calculator specifically which x values I want to look at. I have specific x values here because they gave them to me, right? And if I looked at it in auto mode, I would only get x values that are integers, and these are all decimals, so I'm not going to see them there anyway. So now I'm going to go to the table. You'll notice it's blank. That's okay. I just haven't told it anything yet. And I'm going to type in this x value, 0.38, press enter, and see if I match. And I'm pretty close here, right? And again, remember it said approximately. So now let's check the next example, 2.62, because of course, oh yeah, I got this one, but it says only. You need to check all of your choices, because what if you made a mistake? You won't realize it until you check every single choice to be sure. So the second choice looks almost approximately equivalent as well. So now I can take a look at choice 3 that says both of these work, which is the correct answer, but let's double check the second example. We already know 0.38 works, but what about 3.85? And you'll see that these are not approximately equivalent. So the answer is choice 3. For number 11, the expression negative 4.9t squared plus 50t plus 2 represents the height in meters of a toy rocket t seconds after launch. The initial height of the rocket in meters is. Anytime they ask you for an initial value, this is always when your independent variable is equal to 0. So in this case, it's going to be whenever x is equal to 0, or for us, our x's are actually t's, so it's when t is equal to 0. So I can put this into y1 and take a look at what it would be if I plugged in 0. So I'm going to clear these out, type in negative 4.9x squared plus 50x plus 2. Remember, we always use x's in the graphing calculator. Second window to check and make sure I'm still in ask mode. And then go to the table. I already have some things in here. I can press delete to get rid of them. And I want to see the initial height of the rocket in meters is, so I'm going to type in 0. What is the initial height? 2. Alrighty. Lastly, if the domain of the function, so here's our function, is negative 2, 3, and 5, then the range is, so domain is the set of all x values, and the range is the set of all y values after I've put in the x values. So these are all x's. So what I'm going to do is go back to y equals. I'm going to type in the function 2x squared minus 8. Go to my second window. I'm still in ask mode because these are the 3 I want to ask about. And I'm going to go to the table, clear this out, and type in negative 2, 3, and 5. These 3 values are my domain, which means that these 3 values are the range. So our answer is choice 3. All right, I hope you enjoyed. Thank you for watching. I will put the next video up shortly. Bye-bye.